In this video, we are going to be going over what is and is not a function. So, to kind of reiterate what you saw previously in the problem with the soda machine, I wanted to kind of elaborate a little bit more. So, when we say something is a function, it means that we have one input to one output. This can also mean that I have two or more inputs that go to one output. That's acceptable. On the other hand, not a function is when there's one input that goes to more than one output. So, kind of like the soda machine, if I press a button for blast and I get blast, that's fine. But if I press a button for blast again and I get something like lemon twist, then it's broken. It's not working, right? So, in this case, this is kind of what we are visualizing. So, this is what we call a mapping. I'm mapping the numbers here, my input or my x's, to some y's. To say it's a function, I'm saying that it's either one to one. So let's say I have one maps to one, or that I have two inputs that map to one output. So let's say 2 goes to 2, but 3 also goes to 2. So this right here is a function. Whereas if I'm looking at this mapping of my x's and y's, if I have 1 maps to 1, but also maps to 2, then it's a problem and it is not a function. So the question then becomes, how can we tell when we're looking at it on a graph or a table? So in this, we're going to look at a few different examples. So again, to be clear, a relationship between inputs and outputs is called a function if the inputs and outputs behave like the soda machine. So over here, we're going to see that we have 3 different types of graphs and then a table. And I want to know what is a function, what is not a function. So one of the easiest ways to tell based on a graph is what's called the vertical line test. So I'm going to write that right here. Vertical line test. The idea behind this is if I have a vertical line going through a point, I want to know, does it hit just one point or does it hit multiple points? So if it hits only one point, it's good, it's a function. If it hits multiple points, it's not a function. So first thing I want to test is this one right here. So the easiest way to do it is looking at these lines. I can line it up and go, okay, I don't see multiple points that are running through that, nor here for any of these, right? So we can tell here that this is indeed a function. So each of these points represents one input to one output. Now, when we get to this one, it's pretty clear that if I put my pen right here, you can see that multiple points are being hit. So for example, on my y-axis, this function hits here, or this graph hits here, 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 and here. So that means when x is 0, y is all of these different points. So just based on that alone, it means that is not a function. So that means that I have one input with multiple outputs. The next one down here for this table, it's kind of tricky. It's trying to trick you, honestly. So if you notice, I have repeats in my output. I have 11 repeated. I have 3 repeated. But if you look at the input, these are the same points. So I'm going to cross this one out because it's the same point. So the next one we need to worry about then is this 4, 3, 6, 3. So by definition of a function, I can have more than one input going to one output. So 4 mapping to 3 is okay with 6 mapping to 3. It would be a problem if it were the other way around, where I had 3 mapping to 6 and then 3 mapping to 4. But in this case, it's okay. So this is a function where two inputs map to one output. The next one we're going to look at, and the last one, is this right here. So similar to the other graphs, I'm going to just kind of roll my pen over here, and I can see that there isn't a place where I'm going to have multiple outputs for one input. So then again, this right here is a function.